Hey everyone, welcome to Code Upwards, where we break down algorithms, data structures and LeetCode problems in a simple and engaging way. Today we're solving LeetCode 3, longest substring without repeating characters. A classic sliding window problem that often appears in coding interviews. By the end, you'll understand how to use the sliding window technique to solve similar problems efficiently. Let's dive in. First of all, let's give it a read. Given the string s, find the length of the longest substring without repeating characters. Okay, let's try to understand what this means. A substring is any part of this string of consecutive elements. So ABC would be a substring, BCB would be a substring, ABC would not be a substring because we would be missing the C here. So that's a substring. Now we're looking for the longest of the substring without any repeating characters. So any substring where every character in it only appears once. Looking at this example, the longest consecutive substring would be this one or this one. They're both the same, or this one or this one. They all have 3 characters that are not repeating. Okay, so one brute force approach to do this would be to test all possible substrings and check if they have no repeating characters, and then just save the length of the longest one. So we check A, and then we check AB, and then we check ABC, and then ABCA, and so on. And after we've done the first iteration, we would check B, and then BC, and so on. But this, as you can assume, is not very efficiently and will give us a square runtime of O(n) squared, assuming that n is the length of this string. And what if I tell you that we can do it in O of n, in linear runtime? Okay, so let's try to understand what we are actually looking for. When we start a new sequence, or a new substring, let's start with A, because we're at the beginning. Now the question is, can we extend the substring to the right by 1? So can we add B to our substring? We can add B to our substring if we have not already seen B before, if B is not already part of our substring. So we need a way to efficiently look up if we have seen a character before or not. And as you maybe remember from our longest consecutive subsequence video, a set is the ideal structure for this. So we are keeping a set to keep track of characters we have already seen. So we start by A, say, okay, this is our substring of length 1, we have not seen A, so let's save A here. Now the question is, can we extend our substring to B? So we want to extend it to B. Have we seen B before? We check in our set. No, we have not seen before. So we can extend our substring by 1. And we'll save B here to mark it as seen. Now we want to extend it with C. Have we seen C before? We check. No, we have not seen it. So we can extend our substring and mark C as seen. Now we come to the A. We want to extend our substring, but we have already seen A before. So what do we need to do? This is a classic sliding window problem where we have a window that's marked by 2 indices, so left and right. And we greedily want to expand to the right, like we did here. Every time we want to expand by 1 item, check if a certain condition is met, and if yes, we can move R to the right. And if we see that the condition is not met, we need to move our left indice as far to the right until the condition is met again. So what we want to do, we want to add A to our subsequence, to our substring. So we need to move L as long to the right until we have not seen A anymore. So we check, okay, currently L is here, this is at A. So if we would move L to the right by 1, if we would move it here, then A would not be part of our substring anymore. So we will move L by 1, and we can get rid of this A. Now we would remove the A here and take this A into our substring and add A back. To make it a little bit more clear, I've prepared this example here. So let me empty my set, and I will start with 2 pointers. In the beginning, L and R are in the same place. So our substring has length 1, we have A, we've seen A, we'll mark it as red. Then we move R to the right by 1. Now, have we seen B before? No, we have not. So we mark it as seen. Our current sequence has length 2. So we go on. We move R to the right again. So we're at C. Have we seen C before? No, we mark it in here. So currently our longest subsequence is of length 3. Now we want to move R to the right again, and we are at B. Have we seen B before? Yes, we have. It's in our set. So we need to move L as far to the right until we have not seen B anymore. So we move L here. So A is not part of our substring anymore, so you can remove A here. But still, we have not removed B from our substring, so we need to go on. So we move L one more. Now we can remove B, and this B is not part of our substring anymore. And now the substring from L to R is again valid, because it's CB. They are all unique. Now we need to add B back, because B is again part of our substring. So now our condition is met again, and that's why we can move R to the right. Include D, add D to our set, and then move R to the right again, include E, mark it as seen, and now, as you can see, our current longest substring is of length 4. So this is a typical example of a sliding window approach. We have 2 pointers, L and R, marking the beginning and the end of the sliding window in which the condition is met. Let's dive into the code. Okay, so first of all, we need to initialize our set, where we keep track which values we have seen. Then we need a variable to keep track of the longest substring so far, and we need our left pointer, which we initialize with 0. Now we want to iterate through the string s and we'll move our right pointer by 1 every time, as long as the condition is met, and when the condition is not met, we need to adjust our left pointer and move it to the right until the condition is met again. So we say for right char in enumerate of s. So this in every iteration will give us the right pointer and the character where the right pointer is currently pointing at. Let's say okay. Now let's handle the case where the condition is not met. So if the condition is not met, when is it not met? It is not met if char is already part of char set. So while char in char set, what do we need to do? We need to move our left pointer by 1 and remove the element where left was pointing to. So we say okay, char set dot remove of s at point left, and then remove left by 1. We'll do this as long until the current char is not part of char set anymore because we have removed the duplicate value. And now let's handle our normal case. We can now add our current char, and we can say, okay, let's compute what is the longest substring. Okay, the longest is the maximum of longest we have seen before, and then right minus left plus 1. Why do you need the plus 1? If right is pointing at element 3 and 2 is pointing at element 2, both are part of the substring, but 3 minus 2 is 1, so we need to add 1 to include the element at the border. Okay, after we have run through the whole string, we can then return longest. Let's run the test cases. Looks good. And now let's submit it. And that gives us a very efficient solution. And that's how we solve LeetCode 3 longest substring without repeating characters using the sliding window technique. Thank you for watching, and I'll see you in the next one. Keep coding upwards.